Echom Up-Armored. German company Meller Protection has introduced the innovative exoskeleton. Echom with reinforced armor C capable of protecting against direct hits from armor-piercing bullets, but that's not the only innovative part of this device. The exoskeleton also redistributes up to 70% of the load, allowing soldiers to carry heavy equipment or ammunition. Additionally, thanks to its special design, the mechanical skeleton provides a high degree of mobility, which is vital when moving through challenging terrain or in confined spaces. Unlike other similar devices, ExxonMobil does not require external power sources, heavy batteries, or charging equipment. This feature allows it to be used for long missions or combat tasks in remote locations. 3D printing with liquid metal. MIT researchers have developed an additive manufacturing technique that can print rapidly with liquid metal, producing large-scale parts like table legs and chair frames in a matter of minutes. Their technique, called liquid metal printing (LMP), involves depositing molten aluminum along a predefined path into a bed of tiny glass beads. The aluminum quickly hardens into a 3D structure. The researchers say LMP is at least 10 times faster than a comparable metal additive manufacturing process, and the procedure to heat and melt the metal is more efficient than some other methods. The technique does sacrifice resolution for speed and scale. While it can print components that are larger than those typically made with slower additive techniques, and at a lower cost, it cannot achieve high resolutions. For instance, parts produced with LMP would be suitable for some applications in architecture, construction, and industrial design, where components of larger structures often don't require extremely fine details. It could also be utilized effectively for rapid prototyping with recycled or scrap metal. In a recent study, the researchers demonstrated the procedure by printing aluminum frames and parts for tables and chairs which were strong enough to withstand post-print machining. They showed how components made with LMP could be combined with high-resolution processes and additional materials to create functional furniture. Quarterhorse Mk. In 1976, an State Route 71 soared over Beale Air Force Base at a speed of 2,193.2 miles per hour, breaking the all-time jet-powered airspeed record. The record has not been broken since. Our goal of making hypersonic aircraft mainstream begins with Quarterhorse. Its mission is to demonstrate that our turbine-based combined cycle engine, Chimera, can transition from turbojet mode to ramjet mode in flight. If successful, we'll surpass the SR-71's long-held record. At less than 40 feet in length, this small aircraft will provide an extensive amount of development and testing learning, which in turn will de-risk our future vehicles, Dark Horse and Halcyon. Once in production, Quarterhorse will be used for commercial testing and development purposes. Quarterhorse won't rush to surpass the SR-71's airspeed record. Instead, it will be part of a deliberate, step-by-step strategy. Just as our business roadmap includes 3 aircraft of increasing complexity, Quarterhorse, Dark Horse, Halcyon, we are currently developing 4 unique Quarterhorse vehicles, each designed for a specific mission. Our rapid prototyping approach deliberately mitigates risk. Rather than consolidating all uncertainties and variables into a single Mach 4 aircraft, we are spreading the risks across multiple vehicles, which will enable us to learn more quickly. This iterative, hardware-intensive method is our key to speeding up aircraft development. White Motorcycle Concepts. The WMC 250 EV is the first project of many that White Motorcycle Concepts has in the pipeline and has set the standard and blueprint for all future projects. The unique selling point of the WMC 250 EV is aerodynamic efficiency. White Motorcycle Concepts, WMC, have completed substantial feasibility studies delivering the data required to more than prove its potential. The performance benefits these studies highlighted are far greater than the WMC team even imagined. The WMC 250 EV will achieve twice the mileage for the same electric charge than the current electric motorcycle market equivalent. Jetpack race will take place. The world's first jet suit race will take place in Dubai on February 28 in collaboration with British technology company Gravity Industries. This spectacular event will showcase the performance and competition of personal flight devices. Gravity Industries has done a solid job of advancing its unique approach to turbine-powered personal flight. Richard Browning's first attempts at Ironman-style jet suits were mentioned nearly 7 years ago. The company has managed to differentiate itself from other competitors in the field of turbine-powered personal flight devices. Mayman Aerospace specializes in traditional-looking jetpacks and flying motorcycles, while Zapata develops jetboards and high-speed flying go-karts. The Jetman team stands out with its lightning-fast jet wings. In Gravity's jet suits, turbines in the arms better distribute weight across the wearer's body weight and can be used to maneuver. This allows the suit to deliver an incredibly agile and fun flying experience. But this amazing experience comes at a cost. To buy a 1,050 horsepower, 27 kilograms jet suit, you need to pay $483,000 plus tax. However, those who want to experience this experience at a more affordable price can pay $3,500 and fly in a jet suit on a training platform for a day. Under an agreement with the Dubai government, the race will take place in the area between Dubai Port and Skydive Dubai as part of the Dubai Boat Show. One of the pilots, Ahmed Al-Shehi, and 7 other pilots plan to participate in the competition after training at Gravity. WaveRoller. Wave energy is the single largest and used renewable energy source on the planet. The total theoretical wave energy resource worldwide stands at an impressive 30,000 TWh/year, surpassing the combined human consumption of electrical energy. If this energy could be properly harnessed, it would increase the share of renewable energy production and reduce the reliance on fossil fuels. Unlike some renewable sources, wave conditions are highly predictable, allowing grid operators to forecast them days ahead with remarkable accuracy. This predictability, coupled with the extended use of wave energy converters, is expected to provide up to 10% of the EU's energy by 2050, reducing the need for fossil fuel backup generators. The EU aims to have at least 42.5% of renewable energy by 2030. The objective for ocean energy is to have at least 1 gigawatt of installed capacity by 2030 and 40 gigawatts by 2050. 40 gigawatts of installed capacity would be enough to supply roughly 40 million homes. Finnish enterprise AW Energy has successfully developed WaveRoller, a technology that converts ocean wave energy to electricity. The machine operates in nearshore areas, approximately 0.3 to 2 kilometers from the shore, at depths of between 8 and 20 meters. Depending on tidal conditions, it is mostly or fully submerged and anchored to the seabed. Voliro T. The multi-purpose robotic flight platform redefining work at height. The Voliro LPS Lightning Protection System tester allows ultra-efficient conductivity testing of the full wind turbine lightning protection system. The 4-point contact measurement capability of the Voliro T platform creates superior confidence in your results compared to non-contact methods. Receptors up to a height of 250 m above ground can be inspected without the need to turn the wind turbine. The Voliro NT bundle offers a comprehensive solution for both wall thickness and coating thickness measurements. It allows for precise measurements in detecting corroded or eroded surfaces from a single side. The bundle includes EMT, electromagnetic acoustic transducer, UT, ultrasonic transducer, and DFT, dry film thickness, sensors. Payloads developed by trusted partners for use with Voliro T. All payloads are verified and tested by Voliro. These payloads leverage the Universal Payload Interface and are fully integrated with software and hardware, all the way from the app interface to reporting. The inspection data is live-streamed to the inspector's tablet and stored on the Voliro T. It has never been easier to develop flying robotic applications. The Universal Payload Interface and the open architecture of our platform provide everything you need to implement groundbreaking ideas. Join the Voliro development program to develop and distribute your flying robotics application. Ingenuity Mars Helicopter. NASA's Ingenuity Mars helicopter has completed 72 flights since first taking to the skies above the Red Planet on April 19, 2021. Far exceeding its originally planned technology demonstration of up to 5 flights. The many highlights of Ingenuity's historic and successful activities on Mars include the first aircraft to achieve powered, controlled flight on another planet, a feat that's been called a Wright brothers moment. Completing 128.8 flying minutes, covering 10.5 miles, 17.0 kilometers, and reaching altitudes as high as 78.7 feet, 24.0 meters. Lisa Pathfinder. tested in flight the concept of low-frequency gravitational wave detection. It placed 2 test masses in a near-perfect gravitational freefall and controlled and measured their motion with unprecedented accuracy in a technique known as precision metrology. To do this, it made use of inertial sensors, a laser metrology system, a drag-free control system, and an ultra-precise micropropulsion system. The mission finished on June 30, 2017, having successfully demonstrated the technology to build ESA's future gravitational wave observatory in space, LISA. The aim of the LISA Pathfinder mission was to demonstrate, in a space environment, that free-falling bodies follow geodesics, the equivalent of straight lines in a curved space, in space-time, by more than 2 orders of magnitude better than any past, present, or planned mission. Specifically, it aimed to demonstrate drag-free and attitude control in a spacecraft with 2 free proof masses, test feasibility of laser interferometry with picometer resolution at low frequency, approaching 10 to 12 MHz, 1/2 in the frequency band 1 to 30 MHz. Test the endurance of the different instruments and hardware in the space environment. Flying hovercraft. This is the hovercraft that glides over land and water yet also soars in the air up to 70 miles per hour with the aid of integrated wings. A 130 horsepower twin-cylinder, liquid-cooled gasoline engine, turbocharged and fuel-injected, drives its 60-inch wood/carbon composite thrust propeller while a 1,100 RPM 34 lift fan inflates its durable vinyl-coated nylon skirt for hovering above the ground. Operating in fresh or salt water and up to 30% inclines over sand, mud, grass, swamp, desert, ice, and snow, its wings and horizontal elevator enable pilots to simply hop over water or land-based obstacles up to 20 foot high, insurmountable to a typical hovercraft. A joystick controls 3 vertical rudders in the elevator, a twist friction lock throttle controls forward speed, and a variable drive system controls the lift fan for hovering. Braking is provided by lowering the lift fan's RPMs, comes to rest on Kevlar composite landing skids. Its low center of gravity and composite fiberglass/PVC hull enable it to operate in winds up to 25 miles per hour and waves up to 6 foot when in flight. 2 9-gallon gasoline tanks provide a 160-mile range. Supports pilot/passenger payloads up to 600 pounds for flight. Requires registration as a boat. Special conditions and guarantee limitations apply. Please call 1-800-227-3528 for details. 19-foot L x 7 feet 8 inches W x 6 feet 6 inches. 1,100 pounds.